Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our tree series, and the question that we have this time is add one row to tree. Okay, so it is an interesting question, really interesting question. So let us have a look into the question that what we have to do into this. So in this question, what will be given to us is a root of a binary tree. Okay, so think that a binary tree will be given to you. Okay, binary tree will be given to you, and after that a value and a depth. These two will be integer. Okay, so this kind of input will be given to you, and what you have to do is the question statement is saying that if I tell you the statement is uh, go to depth d. Simply I'm telling you, simply go to depth d that is given. Okay, d is a depth that is given, so go to depth d and add nodes with values val. Okay, val is the value given to you, so go to depth d and add values val. Okay, so what is the meaning of this? See, let me make a binary tree first. Okay, so that we can understand what is the question statement. So here is a binary tree: 1 2 3, okay, 4 5, not looking like 5, and it is 6. Okay, suppose it is a binary tree. Actually it is a binary tree. Okay, so what we have to do is, see, let me tell you what is depth first of all. Okay, because something depth is given, so you have to understand what is depth. So depth, it is saying that as it is in level 1, right? So it is saying that this is depth 1, this is depth 2, this is depth 3. Okay, and if there is some node at this, then this will be at depth 4. Okay, so this is how it defined the depth. Depth means the level at which it is, at which the node is. Okay, it is at first level, so it is depth 1, second level depth 2, third level depth 3. Okay, so this is what the depth is. Okay, so I hope that depth is clear. And what it is saying, the question statement is saying that at depth d, okay, at a depth d, add nodes, I mean add row of nodes with value val. Okay, what it is mean, what it is means, it means suppose it is saying you are given depth is equals to 2 and value is equals to 7. Okay, so at depth 2 you have to add 7. So how it will be added, let me show you. Okay, let me show you how it will be added and how the output will look like. Okay, because when I will show you the output, then you will feel much comfortable about your thinking that how to do it. Okay, so now the output that we can get is, see, 1. Okay, at depth 2 it is at depth 2, right? It is at depth 1, it is at depth 2. So my depth 2 will become a new depth with value 7, right? This will now become the depth 3. Okay, because we have to make depth 2 as 7 with 7 values. So this will become 7, this will become 7. So at depth 2 I have added this 7 and 7, and the rest of the tree will remain the same. Okay, will remain the same and will added in the same corresponding way. That is 2 was in the left of this, right? So in the left of this 2 will be added, and 4 5 was like this, so 4 5 will remain as same. Okay, and 3 was in the right of this, right? In the right of 1 we have 3, so we'll add 3 in the right of this, right? So now 6 will remain as same. Okay, so this will be the output of this tree when depth will be 2 and value will be 7. So I will keep it aside. Okay, I will keep it aside because we have as the test cases are not present right now for this question also. Okay, so what we are going to do, we are going to match our answer. Okay, so we will keep this as our reference, and now after that we'll match our answer. Okay, this will be the first test case, depth 2 and value 7. Okay, now let us say uh, depth is 3 and value will be suppose 9. At 3 you have to add 9. So how we will do it? So now let us keep it this side. Okay, we'll keep it this side and let us try to make the answer. So the answer that we can get as it will be at depth 3 we have to do this 9, right? So we'll say 1 1. Okay, and then after that we'll have, it is at depth 2, so don't do anything with them. But at depth 3 add 9. Okay, at depth 3 add 9. So here we'll get 9, here we'll get 9, here we'll have 9, here we'll have 9. Okay, and then after that, in the left of it it has 4, in the right of it it has 5, here it has null, so it will remain null, it has 6, so it will become 6. Okay, and we will keep it aside. Okay, so this is what we get for this test case. Okay, for this test case. So okay, one more edge case, that is I think most important. That is, suppose someone is saying at depth 1 add 9 or add 10 or add some value. Okay, at 1 means at root, you have to now add into the root. That means your tree, your root will be changed, see, till now the root is 1, but when we are saying at depth 1 add something, so call let us call 5. Okay, add a node with value 5. So then at that condition you should make a node with 5 and add rest of the tree into the left of it. Okay, it is a edge case. 4, 5, 6. Okay, rest of the tree will remain same, but at one depth, what you should do, you should add this one. Okay, what you should do, you should make a new node. Okay, and add the rest of the tree or the root node to the left of it. Okay, this is what it is saying for depth is equals to 1. Okay, so we will also keep it as a test case. Okay, we'll also keep it as a test case. We'll test into this also. So these are the 3 test cases. And now approach. What could be the approach? So think about it. What could be the approach? And then after that I will tell you that how we can solve it. Okay, so if you are thinking in a correct way, or if you are thinking let's say in the way that you previously have studied. Okay, so what you have studied previously, think again. Think, if you have to add something at depth 3, we can say. Okay, this is depth 1, 2 and 3. Suppose here you at this point you need to add something. Okay, depth 3 means at this point. Okay, this will become the depth 3, so at this point you need to add something. That means after 2. So if you will have these nodes, these 2 and 3, so can you add something into the left of it, something into the right of it, and can add the previous left to the left of it, and the previous right to the right of this one, and the previous right to the right of this one? Can you do this? Yes, of course you can. How you can? See, now your main task is how to get this thing, how to guess this 2, 3, and if you need to add at this point, suppose at this point, after this if you need to add something, then what you need these 3, right? You need these 3. So how you can get this? It is quite simple. Can you see that it is something that is increasing in a radial way? What is it? Isn't it breadth first traversal? Right, we are increasing in the breadth first way, right? You need something that is in the breadth of a tree. So what you do to get some element of the breadth of the tree? I will say we travel in a BFS, that is breadth first traversal. We traverse through BFS. So when we traverse through BFS, we get the required value of a corresponding, or the required, we can say, or the required breadth, right? This is the first breadth, or this is the second breadth, this is third, we can say third level. So it is level order traversal, right? Level order traversal. So this is what we can do. What we will do, see, suppose if I want to add something in my depth 3, right? So I'll get the values of depth 2 and add something into the left of it, into the right of it, and before that I will save its previous left, I'll save its previous right, and I'll save for this one also, and then I will add my required values node. right? Required values node to this one, to these two. Okay, so this is the simplest answer that we can give, right? This is the simplest answer that we can give, and this is the only answer. This is also the answer that you can code. Okay, this is the answer that you can code, not the only answer, but this is the answer that you can code. It is quite simple, right? It is quite simple. What you have to do, simply do the breadth first traversal, save these nodes that are one above to the required depth, to the required depth. Okay, so how you can stop here at this point? See, when you traverse to the complete tree, then at that point you stop at 1, right? You stop at 1 when my size is equals to 1, you stop at that point. So when you need to stop at this, so what you will do, you will simply stop at depth minus minus when it is greater than 2, right? Because we need to stop at this depth, we need to stop at this depth only, because we need to add at depth 3, so we need to stop at depth 2. When we need to add something into depth 3, we need to stop at depth 2. So how you can stop at depth 2? That is when you will stop at 1 will remain. Okay, when 1 will remain. Okay, so that means depth minus minus is greater than 2. So I hope that this point is clear. Okay, this point is clear. Okay, one more thing, the constraints. The constraint will be the depth which will be given, the depth which will be given can be more than the depth of this tree also. Suppose the depth of this tree is 3, right? So depth can also be given as 50. So in this case also you have to manage something, that is you have to return the same thing, that is the same tree, that you cannot do any change in it, so you have to return the same tree in this case. Okay, so I hope all the points are covered, and and also the approaches is covered, right? So what is the approach? Approach is, will traverse in a depth first way, I mean the breadth first way. Okay, will traverse in the level order. Simply I will say we will traverse in the level order, will save this level elements. Okay, and will add its something, and will add the required node to the left and right of it. Okay, and before that I'll save these previous nodes. Okay, and after that, after adding the node into this, I'll add this node again to the left of it, right? Node, it is, suppose it is node. Okay, so first of all I'll save something, that I'll save this, I'm saying this as the node, right? This as the node. So I'll save left is equals to node dot left. Okay, now I saved this. Okay, and right is equals to node dot right, and then I will add this node dot right. I'll make node dot right is equals to new node, right? New tree node with value val. I'll add this into the left of it and into the right of it, and node dot right also, node dot left also. Suppose it is left and it is right. Okay, so I'll add into both left and right my new nodes, and after that I'll add left of left again left, I mean this left of left again will be this L, and right of right again will be this R. Okay, so this is quite simple. Okay, this is quite simple that we are going to do. Okay, so I hope that I have covered all the points that are required, so we can easily code it. So let us try to write the code for the same. Okay, now let us go to code it. So we are going to code in Java, right? So let us write the code for the same. So simply, first of all, let us handle the condition for depth is equals to 1. Depth is equals to 1. Simply make tree node is equals to new tree node of size, new tree node of value val, right? Of value val, and then node dot left is equals to root, right? We'll put root into the left of it, and then we'll write return we have to return the root of the tree that is created, that is new tree. We have to return the root of the new tree, and after with the help of that root that you will return, our compiler will check if it is the right answer or not. Okay, so what we should return from here, the new root is node, right? So we'll return this node now. Yeah, so it is done for 1. Now we need to handle if it is not 1, if depth is not 1. So what we can do, see, if I need to handle for some depth which is greater than the tree depth, okay, which is greater than the tree depth, then for that what I have to do, first of all I have to count the depth of the tree. Okay, I have to calculate the depth of the tree, and need to make a check that when this depth, I mean when this depth, if this depth is greater than the tree depth, okay, then at that point return the previous node. That means return the previous root. Okay, we cannot do anything into this case. Okay, for this we need to return our previous root. But is this a good idea to write a one more function for to calculate depth of the tree and to check again? So I'll not do that. I'll simply, what I'll do, first of all let us make a queue, right? We need, okay, how many queue do we need? It is the question that how many queue do we need. Can you do it with the help of a queue? I'll say no. We need actual we need only the element of a particular what we can say level, right? We need elements of a particular level. So for that, every time when we are completing one level, we need to empty a queue and again need to fill that, right? So for that we need 2 queues. I'll use 2 queues. So queue of tree node, I'll say this parent queue. Okay, pq is equals to new linked list. Okay, so this is what we'll do, and after that in the same way make a child queue also. So make a child queue, that is cq. Okay, so we have 2 queues. Now I'll do the work while see till when I'll do the work, while my depth minus minus is greater than 2, right? While my depth minus minus is greater than 2, till then I'll do the work. And also I'll write pq.size is greater than, what is that, pq.size is greater than 0. Okay, so while my depth minus minus is greater than 2 and while my pq.size is greater than 0. So when my pq.size is greater than 0, then that means that my tree is completely traversed. Okay, one condition will be enough, but I actually added second condition of pq.size greater than 0, because see, if my depth is too much, right, if my depth is too much than that of the actual depth, then this will traverse in a huge way, right? This will traverse really high. So that is why I added this pq.size greater than 0, and second condition, depth minus minus is greater than 2. Okay, so if I get some depth, if I get element of the particular depth, then this condition will hit. Okay, I mean this condition will not be true after that depth, so we'll get the element of that particular depth. Okay, so now I hope that these two condition, why we added these two condition, is clear. So we'll move on, and what we'll do, simply we need to do work for each level, right? So I'll calculate size, pq.size. Okay, that how many elements we have in this particular level. So I'll write while my size minus minus is greater than 0. Okay, so okay, one more thing, I haven't added anything to my pq.add root, right? We have to add a root also, so that we can run our this BFS, right? Because here this condition is false. I mean this condition is already false. pq.size is not greater than 0. Okay, if we will not add anything, then we'll never enter into this loop. So now I added root into it. Okay, so I added root into it. So what we can do after that, we can simply renode rem is equals to pq.remove. Okay, I'll remove from here and will add my child queue, and will add into my child queue, so that I can prepare my child queue for my next level. Okay, so if rem.left is not null, then I will do something. Okay, same for the right. If rem.right is not null, rem.rigst is not null. Okay, so what I'll do, cq.add rem.right. Okay, cq dot add ram dot, oh sorry, cq dot add ram dot left, it will be ram dot left, ram dot left. Okay, and here it will be ram dot right. So after this we'll be done with adding my element and preparing my child queue, right? So my child queue is prepared. So after coming to the next level, okay, before going to the next level, after coming to this particular level and before going to the next level, what I'll do, I'll make my, I'll send my child queue element to my parent queue so that this loop can run again. Okay, so I'll make a queue of tree node. Okay, and that will be this equal to let us say this temp. Okay, and we'll make it equal to pq, and now pq will point to cq. Okay, and my cq will point to temp. Okay, so this is what it will do. And after coming from this while loop, either my pq will be empty or my pq will contain the element of the particular level that I want. Okay, so if it is empty, no worries, that means my depth is greater than the actual tree depth. Okay, so in that case also we need to return root, right? We need to return root. So, and if there is something, then we will what we will do, we'll add my nodes with the required values to the nodes that we have in this queue, right? So let us do that. So while pq will have my nodes, after which we need I need to add my new nodes. Okay, pq dot size is greater than 0, while pq dot size is greater than 0. So for that I will do tree node is equals to pq dot remove. Okay, pq dot remove. So this is what I will do. And after this I'll store my left and right. Tree node L is equals to node dot left. Okay, and tree node R is equals to node dot right. Okay, so this is what I will do. And after this, what I need to do, simply node dot left is equals to new tree node with value well. Okay, same for the right, that is node dot right is equals to new tree node with value well, right? And after that I added a new tree nodes, right? But the previous one is not added now. So node dot left will equals to the original left, right? L, and node dot right will equals to original R. Okay, this is what I'm supposed to do. And after that, after doing this, you simply return the root. Okay, because that will be the answer. Okay, so see, suppose if my pq size is 0 here, okay, that means my depth is greater than actual tree depth. Okay, so at that condition also this will never hit and will simply return root. Okay, so this means that all the conditions are balanced, all the conditions are handled here. Okay, we don't have to make any other check, or we don't have to do anything else apart from this. So now let us check it that is it correct or not. So for that we need to enter a tree for this, right? So let us go to the board. Okay, and we'll enter this tree. Okay, so this will be created in the level order way. Okay, so what is the level order of this? 1, then 2, then 3. Okay, then 3, and then after that we have 4. 1 2 3, then 4 5, then null, then 6. 4 5 null, and then 6. Okay, so this is the input. Okay, so one input I already have given, I think it is the same input. Okay, let us remove this input that is given already, and we will give our new input, that is 1 2 3 4 5 null 6. Okay, 1 comma, not comma, 1 2 3 4 5 null and 6. Okay, and after this, in which level you want to see? Suppose here we have added 5 1. Okay, we have added in level 1, we added 5 in this, right? So we will see this one first. Okay, so in level 1 we will add 5. So first of all we have value or level, in input we have value first, right? value and then depth. So value was 5 and we want this in depth 1. Okay, so give me the tree. It is accepted. So this is the tree that I got. So let us see this tree. Let us observe this. So if I will paste it here, then this is my tree. Okay, this is my tree. So let me make this tree. Let me make this tree. So I hope that now I can remove this. Okay. So let me make this tree. So how this tree will look like? This tree will look like. See, with the help of this color. So 5 in the left of it, we have 1 in the left of it. Okay, it is made in the same way that we were making in our Pepcoding website previously. Okay, it will be made in the same way. So 5 in the left of that will be 1, then in left 2, then in left 4. Okay, we have this, and after that we have null. So null, and after that we have 5. So 5 has null, and after that we'll reach to 6. I mean this one 1. So 1 have 3 in the left of it, I mean right of it, and then it has in the left null, right has 6 has null, and 5 null, right? So this is the tree. Is this the right tree? Yes, it is the right tree. I think here it is something change, because the bug in the open mode when I'm doing control Z, right? So when I'm doing undo, then at that time it is I think changed. But suppose if you need to add 5 here, so this will be the tree, right? This will be the tree. So this is the output, same as that. Now let us see some other case. So some other case could be same will be the input. Okay, input will be the same, but what we will do till now, input will be the same, but we will add into some other level, right? Here we added in level. In this test case we added in level, this is level 1, level 2. Level 2 we added 7. At level 2 add 7. Go to level 2, add 7. Value will be 7, level will be 2. Okay, give me the tree. So the output is net. Okay, net is correct. Here we got let me simply here paste this. Okay, now we have this, right? So let us see what is this tree. So this tree is 1, then after that 7 in the left, then 2 in the left, and then after that 4 in the left, then null. Okay, then 5 here. Okay, and after that null for 5, then null for 7. Okay, and after null for 7 we have 7 for the left right of 1. Okay, and then left is null, right is 3, then left is null, right is 6, and then null. Okay, so this is the tree. Is this the tree that we're supposed to get? Yes, it is the tree that we're supposed to get. Okay, it is same. So for this also we are getting correct answer. So let us say for one more last test case, and that could be okay. That is we have to add 9 in level 3, right? 9 in level 3. So 9 in level 3. Give me the tree. We got a tree. So let us now make this last result. Okay, it is the tree. Copy code, then paste, right? So let us observe this one. So if you'll observe this one, then this will be it would be like 1, then 2, then 9, then 4, then null, then null. Okay, and then after that 9, then null. Okay, and here we have 5. Okay, null and 5, then null, and after null, we have 3. Okay, 9 here, left 9, and 3 left null, right null. Okay, null for this left will be null, right will be null, and here again 9, and left is null for 9, and right is 6 for 9, and null for this. Okay, so this is the tree that we got. So is this the right tree? So I hope this is the required tree that we are supposed to get. Okay, so it is the answer. So I hope that you got this question completely. Okay, and as the test cases were not present, and so for that we checked in this way. Okay, so it also it was also an advantage for you that you got how to make trees with the help of level order also. Okay, how to make trees with the help of level order, and how we are making trees in our Pepcoding website previously. Okay, you got that point also. So this is our code. Okay, so I hope you understand this code completely, and also this approach that we have used. So that's all for this video. We'll meet in the next video, and when you will submit this, we'll also be ready with the test cases. Okay, so when you will submit it, the test cases, when you will submit this question, you will get the points for that. Okay, that you get in questions previously, like previously you will get the points for this one also. Okay, so that's all for this video. So we'll meet in the next video now. So you can like the video if you liked it, and also subscribe to our YouTube channel, share this video with your friends. So that's all for this video. So we'll meet in the next video now. Till then, goodbye, take care, bye.